So when we set out designing this machine, we wanted to produce a product that had the performance of an upright, but we wanted to make a cordless machine that wasn't any heavier or more difficult to use. In fact, we wanted to make it lighter and more maneuverable. So in order to get a machine with the power of an upright, we need to put a powerful motor in it, the V6 Dyson Digital motor. And that's a far more powerful motor, providing a far greater through flow of air watts. We make this digital motor in-house because there isn't a motor on the market that can satisfy the specification and requirements that we need for our machine, but also because we need it to fit within a very specific housing. Our product has a 66mm inner diameter, and we have 6mm on diameter to play with to fit a radial seal. One of the techniques we used to get around this was to direct the airflow around the motor as well as through the centre of the motor to optimise how space was used within the motor bucket. In previous machines, we've used a V2 motor. We had several different electrical boards controlling different areas of the product. On the V6 motor, we've managed to combine all of these ancillaries into one board at the back of the motor itself, and that's made the whole unit far more compact.
For the new Dyson Digital Slim, we wanted to release as much flow rate to the cleaner head as possible to maximise the pickup. In order to maximise the efficiency of the cyclone pack, we can use smaller cones. Due to their smaller diameter, we get higher G-force and therefore improved separation. On the previous Digital Slim, we had 6 cones. On the latest product, we've actually got 15 cones, 10 on the lower layer and 5 on the upper. More cones means a less restrictive cyclone, so more product flow rate. And so one of the big challenges was to actually seal off all of these chambers from one another in a very small amount of space. The most obvious sealing solution for us would have been to have around each of these zones, we'd have had 4 separate gasket seals. Having those 4 seals in this area, there just wasn't the space to package it. We actually used an overmould where we injection mould a rubber-like plastic onto an existing plastic part, and it then means it becomes one part, which then inherently takes up a lot less space than having to fit these individual gaskets to this plastic part.
So when designing this machine, we were trying to get the centre of gravity above the user's hand to improve the balance. The grip here is far further forward in comparison to how it has been on our previous products. So although we're already saving weight, we are also making it feel lighter in the hand. The whole product itself is tuned to achieve a certain specification. We've added more power through a combination of V6 and the Cyclone tuned to work with the V6, as well as the latest technology in the battery pack.